The Copper Resonance, a chronicle of New Haven's first exchange. Close your eyes. Imagine the year is 1877. The air in New Haven, Connecticut is heavy with the scent of coal smoke, damp earth, and the faint, salty breeze blowing in from Long Island Sound. You are walking down Chapel Street. The pace of life is dictated by the steady clop-clop of horse hooves against cobblestones. There's no digital hum, no cellular signal, no instant connection. There is only the physical world, moving at the speed of a handwritten letter. The dawn of the district telephone company. The story of the first commercial telephone exchange does not begin with a shout, but with a series of very quiet, very technical experiments. In a small office at 219 Chapel Street, a man named George Coy was looking at a piece of wire. To the average passerby, George Coy was simply a telegraph man, a man who understood the language of dots and dashes. But Coy was thinking about something much more tedious and eventually revolutionary. He had attended a lecture by Alexander Graham Bell at the Skiff Opera House earlier that year. While others were amazed by the magic of the voice traveling through wire, Coy was preoccupied with the logistics. If 2 people wanted to talk, they needed a wire between them. If 3 people wanted to talk, they needed more wires. If a city wanted to talk, they would need a web. The mechanics of the mundane. In late 1877, the concept of a switchboard didn't exist in the way we visualize it today. There were no plastic components. Everything was wood, brass, and gutta-percha insulation. Coy partnered with Herrick Frost and Walter Lewis. Together, they formed the District Telephone Company of New Haven. Their initial capital was modest, but their patience was infinite. They began by surveying the rooftops. In the 1870s, you didn't bury cables underground. You strung them from chimneys, from church steeples, and from dedicated wooden poles that began to sprout like thin, leafless trees along the New Haven skyline. Think about the wire itself. It wasn't the sophisticated fiber optics of today. It was galvanized iron wire. It was stiff. It was prone to rusting in the humid Connecticut summers. It hummed when the wind blew from the north. Workers had to climb ladders, heavy wooden ladders, to manually wrap this wire around porcelain insulators that looked like small white teacups. The first 21. By January 1878, the exchange was nearly ready. It didn't serve thousands, it served 21. 21 brave, perhaps slightly confused subscribers who agreed to have a bulky wooden box fastened to their walls. Among these subscribers were the local police station, the post office, a few drugstores, and a handful of private residences belonging to men who liked gadgets. There were no phone numbers yet. Why would you need a number when there were only 21 people to call? You simply picked up the receiver and waited for the operator, usually a teenage boy in those very early days, to ask who you wanted to speak to. The switchboard Coy built was a marvel of boring engineering. He used pieces of carriage bolts and wire from discarded bustles, the metal frames women wore under their skirts. It was a Frankenstein's monster of spare parts, ticking and clicking in the dim light of the Chapel Street office. The Bustle-Wire switchboard and the first telephone directory. To understand the evolution of the Connecticut exchange, one must understand the physical texture of the equipment. There were no standardized parts in 1878. There was no Bell system manual. There was only George Coy and his collection of scavenged materials. The anatomy of the first switchboard. Imagine a wooden board, roughly the size of a small desk, leaning against a wall. This was the heart of the New Haven exchange. To build the switching mechanism, Coy famously used metal pins and wire taken from ladies' skirt bustles. In the Victorian era, these wire frames gave dresses their shape. In the New Haven telephone office, they became the conductive pathways for human speech. The board featured 2 main components. The annunciators. These were small electromagnetic shutters. When a subscriber cranked the handle on their telephone at home, a small electrical pulse traveled down the iron wire, causing a shutter on Coy's board to drop with a soft clack. This was the visual signal that someone wanted to talk. The connection pins. Once the shutter dropped, the operator, initially Coy himself or a young boy in those very early days, would take a brass plug attached to a flexible wire and insert it into a hole corresponding to the subscriber. The sound in the room was not the digital silence we are used to. It was a rhythmic, mechanical symphony. The metallic click of the shutters, the scrape of brass against brass, and the low, muffled voices of the operators repeating names. There were no hellos yet. That would come later. People often started conversations with a stern, "Are you there?" or a simple "Ahoy." The first telephone directory, a single sheet. On February 21, 1878, the District Telephone Company of New Haven published something that would eventually become a thick yellow book found in every American home. But at this moment, it was just a single thin piece of paper. It didn't list phone numbers. Numbers were considered too impersonal and unnecessary for a community of acquaintances. Instead, the directory listed names and categories. It was divided into 5 sections. Residential. Only 11 names appeared here, mostly the wealthy elite of New Haven who lived in the grand houses near Yale University. Professional. Doctors and lawyers who wanted to be reachable in emergencies. Miscellaneous. Small businesses that were curious about the new toy. Public offices, the police and the post office. Stores and factories, meat markets and hardware shops. Imagine the paper itself. It was likely printed on a manual press, the ink slightly raised, the edges perhaps a bit uneven. It was a list of pioneers, though they didn't know it. They were simply people willing to pay $1.50 per month for the privilege of being connected to 20 other people. The operators, the rude boy era. In these first few months, the voice of the exchange was not the polite, professional woman we associate with old-fashioned switchboards. It was the telegraph boy. Telegraph companies had always employed teenage boys to run errands and tap out Morse code. Naturally, they were the first choice for telephone operators. However, they were a technical disaster. These boys were often loud, prone to playing practical jokes on callers, and would occasionally get into verbal arguments with the subscribers. The atmosphere in the New Haven exchange was chaotic. The boys would shout across the room to one another, their boots scuffing the floorboards, while the smell of ozone and hot metal rose from the primitive batteries lining the walls. These batteries, large glass jars filled with acid and lead, required constant maintenance. They had to be topped off, cleaned of corrosion, and monitored for leaks. The evolution of the exchange was as much about managing these leaky batteries and rowdy boys as it was about the science of sound. From boisterous boys to the voice with a smile. The early days of the New Haven exchange were loud. The teenage boys employed as operators, many of whom had transitioned from being telegraph messengers, brought a certain street-level energy to the switchboard. They would wrestle, shout at subscribers who were too slow to speak, and occasionally use colorful language that shocked the Victorian sensibilities of New Haven's elite. The atmospheric noise of the exchange. Imagine the soundscape of the small office at 219 Chapel Street. It wasn't just the boys shouting. The technology itself was noisy. Because the wires were made of galvanized iron and strung haphazardly across rooftops, they acted like giant antennae. They picked up the hum of the wind, the crackle of distant lightning, and the leakage of telegraph signals from nearby lines. When a subscriber picked up their heavy wooden receiver, they didn't hear a clear tone. They heard a cacophony of induction hum, a low-frequency vibration, crosstalk, faint voices of other people talking on parallel wires, and mechanical clatter, the constant dropping of the metal annunciator shutters on the board. George Coy realized that if the telephone was to become a tool for the masses, the environment had to change. The chaos of the boy operators was bad for business. By the late 1870s and into 1880, New Haven began to pioneer the transition to female operators. Women were seen as more patient, had higher-pitched voices that traveled more clearly over the scratchy iron wires, and were generally more polite to the disgruntled businessmen who were still skeptical of the $1.50 monthly fee. The rooftop spiderwebs. As the list of 21 subscribers grew to 50, then 100, the physical geography of New Haven changed. Since the city wouldn't allow the tearing up of cobblestone streets to bury wires, the exchange looked upward. Iron wires began to crisscross the sky in a literal spiderweb. Each new subscriber required a dedicated wire running from their house all the way back to Chapel Street. Consider the logistical boredom of this task. First, the bracket. A lineman would have to bolt a wooden or iron bracket to a chimney. Then the insulator. A glass or porcelain knob was screwed onto the bracket. Then the sag. The wire had to be pulled tight enough to not touch other wires, but loose enough so that the winter cold wouldn't snap the metal as it contracted. If a heavy sleet storm hit New Haven, which happened often in February, the weight of the ice on these hundreds of thin iron wires would often pull down entire chimneys or snap the poles. The evolution of the exchange was a constant battle against gravity and the New England weather. The invention of the call. During this period, the way people used the phone was also evolving. In the very beginning, you didn't dial. You signaled the operator and they would manually connect you. But how did you get the person on the other end to know someone was calling? Early phones didn't have bells. Some had a small thumper that tapped on the diaphragm to make a clicking sound. Others required the operator to literally shout into the line, hoping the person on the other end was standing near the wall-mounted box. Eventually, the magneto generator, a hand-cranked dynamo, was added. This allowed the user to turn a handle, generating enough electricity to ring a bell at the other end. The rhythmic crank, crank, crank of the telephone handle became the new background noise of Connecticut life. The iron barrier and the birth of the toll. In 1880, long distance didn't mean calling across the country. It meant trying to hear a voice in Bridgeport or Hartford, cities only 20 to 40 miles away. For the operators in the New Haven exchange, these few miles represented a massive technical wall. The problem with iron wire. The first lines in Connecticut were made of galvanized iron. While iron was strong and cheap, it was a terrible conductor for the delicate electrical impulses of the human voice. Imagine the physics of a call from New Haven to a neighboring town. Resistance. As the wire grew longer, the electrical signal grew weaker. By the time a voice traveled 15 miles, it often sounded like a faint, ghostly voice buried under a mountain of static. The hum, because these wires were unshielded, they acted like giant antennae. They picked up the rhythmic clack-clack of telegraph lines running parallel to them. If a thunderstorm was brewing 50 miles away, the telephone receiver in New Haven would crackle with the sound of frying bacon. Engineers of the New Haven exchange spent hundreds of hours simply listening to the silence of the wires, trying to figure out why the signal vanished. The solution was copper wire, but copper was soft and would stretch or snap under its own weight when hung between poles. It wasn't until Thomas Doolittle, working in nearby Ansonia, Connecticut, perfected hard-drawn copper wire that long-distance calls became possible. This transition was slow, expensive, and required linemen to replace thousands of miles of iron wire, one pole at a time. The evolution of the hello. During this period, the social etiquette of the telephone was still being debated. How did one start a conversation? Alexander Graham Bell, the inventor, preferred the nautical term ahoy ahoy. He felt it was a sturdy, commanding way to get someone's attention through the static. However, his rival, Thomas Edison, suggested a simpler, flatter word, hello. In the New Haven exchange, the ahoy versus hello debate was a daily occurrence. The operators, now increasingly young women known as hello girls, eventually standardized the term. Hello, which had previously been used mainly to express surprise like, hello, what's this, became the universal greeting of the telephonic age, born largely out of the need for a clear, sharp sound that could cut through the electrical hum of the Connecticut wires. The first toll and the ledger. As the New Haven exchange connected to other towns, a new bureaucratic layer emerged, the toll. Previously, you paid a flat monthly fee to talk to your neighbors, but calling long distance required more equipment and more operator time. This led to the creation of the toll ledger. Imagine a large leather-bound book sitting on a desk in the Chapel Street office.
Every time a caller asked to be connected to a town outside New Haven, the operator had to look at the mechanical clock on the wall, write down the caller's name and the destination, note the exact minute the connection was made, note the exact minute the connection ended, and calculate the fee, often a few cents per minute. This was the birth of the itemized bill. It was a slow, manual process that required the operators to be both switchboard masters and amateur accountants. The evolution of the exchange wasn't just about wires. It was about the growing mountain of paperwork required to keep the wires buzzing.
The Great White Silence and the Underground Evolution. By 1887, the District Telephone Company of New Haven had expanded significantly. The poles lining the streets had grown taller, some reaching 50 feet into the air, carrying dozens of crossarms. Each crossarm held 10 glass insulators, and each insulator held a wire. To a resident of New Haven, the hum of the wires in a light breeze was a constant low-frequency background noise, a literal vibration of the city's nervous system. The Great Blizzard of 1888. In March 1888, the Great White Hurricane hit Connecticut. It wasn't just a snowstorm, it was a technical execution for the overhead wire system. Imagine the physics of the disaster. The accumulation. Wet, heavy snow began to cling to the thousands of miles of thin wire. The ice crust. As the temperature dropped, the snow turned to ice. A wire the thickness of a pencil suddenly became as thick as a man's wrist. The leverage. The wind, gusting at 60 miles per hour, caught these ice-coated sails. In the New Haven Exchange office, the annunciator shutters began to drop in rapid succession, not because people were calling, but because the wires were snapping and short-circuiting. One by one, the voices of New Haven went silent. The weight was too much for the wooden poles. They snapped like toothpicks, bringing down chimneys, storefronts, and the very connectivity the city had come to rely on. The tedious task of the conduit. The aftermath of the blizzard led to a realization that would define the next decade of the Connecticut Exchange. The wires had to go underground. This was not an easy or exciting task. It involved the evolution of the trench. For years, New Haven streets were perpetually torn up. Laborers with pickaxes and shovels dug long, narrow channels through the frozen earth and the summer mud. The technical challenge was insulation. You couldn't just throw bare copper wire into a hole. The New Haven engineers had to experiment with lead sheathing, wrapping bundles of wires in heavy lead pipes to keep out the moisture of the Connecticut water table, creosoted wood, placing the lead pipes inside wooden ducts treated with tar to prevent rot, and the manhole, designing the brick-lined underground chambers where technicians could climb down and manually splice wires together. The work was dark, damp, and incredibly slow. A team of men might only progress a few yards a day. The evolution of the exchange moved from the high, airy rooftops down into the silent, cramped darkness of the New Haven soil. The introduction of the metallic circuit. While the wires were being moved underground, a major electrical shift occurred. Originally, the telephone used a ground return system. One wire went to the customer, and the electrical circuit was completed by literal grounding it into the earth. However, as New Haven modernized and added electric streetcars, the ground became noisy with stray electricity. Callers in New Haven started hearing the hum of the trolley motors in their ears. To fix this, the exchange had to move to a metallic circuit, 2 wires for every single phone. This effectively doubled the amount of boring, repetitive work for the linemen. Every connection, every solder, every terminal had to be done twice. The switchboard grew twice as complex, and the cable bundles grew twice as thick. The standardization of the desk and the birth of SNET. By 1890, the physical act of making a call in Connecticut was becoming a routine. The novelty had worn off, and the era of the black box had begun. In the earlier days, every telephone looked different. Some were shaped like coffins, some like small desks, and some were literally just parts screwed into a wall. SNET realized to manage thousands of customers, every piece of equipment had to be identical. The evolution of the solid back transmitter. If you were a subscriber in New Haven in 1892, your telephone probably sat on a desk. It was a heavy cast-iron object known as the long-distance transmitter or the oil can phone. The technical evolution here was hidden inside the mouthpiece. Early transmitters used loose carbon granules that would often settle or clump due to the humidity of the Connecticut shoreline. If the granules clumped, your voice would sound faint. The boring solution, users were instructed to occasionally tap the side of the phone with a pencil to loosen the carbon. The engineering fix was the solid back transmitter, which used a small brass chamber to keep the carbon granules in a state of constant, perfect tension. This allowed for clearer calls, but it meant that SNET technicians had to visit almost every home in New Haven to swap out the old, unreliable mouthpieces for the new, standardized ones. The rise of the number. As the exchange grew toward 1,000 subscribers, the name system finally collapsed. It was no longer efficient for an operator to remember where Mr. Smith the blacksmith lived. In the New Haven central office, a new cold logic was applied: the telephone number. To the residents of New Haven, this felt impersonal. You were no longer a person, you were New Haven 402. The operators had to learn a new way of thinking. Instead of looking for a name on the board, they looked for a grid coordinate. The switchboard itself evolved into the multiple switchboard. This was a massive technical undertaking. In a large exchange, you couldn't have just one board, you needed several, but every operator needed to be able to reach every subscriber. The solution was to multiply the jacks. Every single subscriber's line was wired to appear on every single section of the long switchboard gallery. Imagine the back of that switchboard, a literal mountain of copper wire, tens of thousands of individual solder points, all color-coded and laced together with waxed twine. One mistake, one crossed wire, could mean that when you tried to call the doctor, you ended up talking to the local brewery. The bureaucracy of the central office. With the birth of SNET, the office at 219 Chapel Street became too small. The exchange moved to larger, more formal quarters. This introduced a new layer of boring social hierarchy. The chief operator, a stern woman who patrolled behind the seated operators, ensuring no one spoke unless it was to facilitate a connection. The wire chief, the man responsible for the MDF, or main distribution frame, where the underground lead cables finally emerged from the floor to meet the switchboard. The ledger clerks, rows of men and women who did nothing but process the thousands of paper toll tickets generated every day. The evolution of the exchange was now a matter of logistics and accounting. Every hello was tracked, timed, and filed. The magic of the telephone was being replaced by the steady, rhythmic hum of a well-oiled corporate machine.
The rise of the machine and the Strowger step. By 1900, the Southern New England Telephone Company, SNET, was managing a sprawling network. In New Haven, the central office was a hive of activity, but a new invention from a disgruntled undertaker in Kansas City was about to change the literal dial of history. Amon Strowger had invented the automatic switch because he believed manual operators were diverting his business calls to a competitor. While New Haven didn't switch to full automation overnight, the evolution of the dial began to creep into the engineering discussions at the Chapel Street headquarters. The physics of the click were: before the dial, you picked up the phone and waited. With the introduction of the step-by-step switch, the user became the operator. Imagine the mechanical tedium of a 1900s automatic exchange. The pulse. When you rotated a dial, you weren't sending a digital signal. You were literally opening and closing a circuit. If you dialed the number 3, the line would disconnect and reconnect 3 times in rapid succession. The commutator. Inside the exchange, a large mechanical arm would step up 3 notches, then wait for the next set of pulses to swing across to the next contact. The sound. An automated exchange wasn't quiet. It was a cavernous room filled with the sound of thousands of metal wipers clicking, sliding, and snapping into place. It sounded like a field of metallic crickets. The loading coil and the rural expansion. While the city of New Haven was getting faster, the rural outskirts of Connecticut, places like Hamden, Woodbridge, and North Haven, were still struggling with the faint voice problem. As lines stretched into the hills, the electrical signal naturally dissipated. The solution was the loading coil, invented by Michael Pupin. These were heavy iron core inductors placed in weatherproof pots every few miles along a telephone line. The installation. Linemen had to haul these heavy iron pots up poles in the middle of winter. The splicing. Each coil had to be perfectly spliced into the copper pair. If the seal on the pot leaked, even a drop of Connecticut rainwater would short out the entire long-distance line to Hartford. The maintenance. Because these coils were physical magnets, they were prone to being fried by lightning strikes, requiring a technician to drive a horse and carriage out into the countryside to find the one burnt-out coil in a 10-mile stretch. The bureaucracy of the directory. As the exchange hit the 5,000 subscriber mark, the single sheet of paper from 1878 had evolved into a thick, bound book. The yellow pages were born out of a shortage of white paper in a nearby printing plant, but they became a New Haven institution. The task of compiling the directory was an exercise in extreme administrative boredom. Every name, every address, and every 4-digit number had to be typeset by hand using lead blocks. A single typo might mean a prominent businessman might receive calls for a local stable for an entire year. The directory department at SNET became a permanent fixture, filled with clerks who did nothing but cross-reference handwritten ledger entries with printed proofs. The evolution was no longer about a man with a wire. It was about an army of clerks with fountain pens and a room full of clicking mechanical arms. The French phone and the architecture of silence. By 1924, the New Haven Exchange was overseeing a cultural shift. The handset, which combined the speaker and the microphone into one single molded plastic and metal, was finally becoming the standard. Though it was nicknamed the French phone because similar designs had been used in Europe for years, the American version had to be engineered for the specific, rugged conditions of the Connecticut electrical grid. The problem of side tone. The technical reason it took so long for the New Haven Exchange to adopt the handset was a boring but persistent problem called side tone. In early handsets, the vibrations from the transmitter, where you speak, would travel through the handle directly into the receiver at your ear. This caused a loud, distracting echo of your own voice. New Haven engineers spent years testing different materials, Bakelite, hard rubber, and even various types of wood to find a way to dampen these internal vibrations. The solution was a complex anti-side tone circuit built into the base of the phone, using a series of induction coils and capacitors. The result: the phone became heavier. The desk set now had a substantial base that sat firmly on a mahogany table, symbolizing that the telephone was no longer a temporary gadget, but a permanent piece of furniture. The Great Exchange Buildings. As the number of subscribers in New Haven surged towards the tens of thousands, the small offices of the past were no longer sufficient. SNET began constructing massive, fortress-like buildings. One of the most iconic was the Art Deco headquarters on Church Street. These buildings were designed with boring longevity in mind. They featured reinforced floors, the weight of the lead-sheathed cables and the massive banks of lead-acid batteries required floors that could support hundreds of pounds per square foot. Cable vaults. In the basement, thousands of pairs of wires entered through concrete ducts. Every wire had to be labeled, fanned out, and soldered to a main distribution frame. The battery room. A silent, pungent room filled with glass jars of acid. This was the heart of the exchange. In the event of a power failure in New Haven, these batteries kept the dial tones alive. Maintenance involved technicians checking the specific gravity of the acid in every single jar, every single day with a glass hydrometer. The first whispers across the Atlantic. In 1927, a momentous but incredibly faint milestone touched the New Haven wires. The first commercial transatlantic telephone service opened between New York and London. While the call didn't originate in New Haven, the long-distance lines connecting New York to the powerful radio transmitters in Maine and Newfoundland ran directly through Connecticut. The New Haven repeater station became a vital checkpoint. Technicians sat in front of glowing vacuum tubes, primitive amplifiers, adjusting dials to ensure that the voice of a businessman in London didn't get lost in the thermal noise of the New England coastline. This was the beginning of global connectivity, but to the man working the 2 a.m. shift in New Haven, it was just a series of needles on a gauge that had to stay between two black lines. The evolution was now measured in decibels and vacuum tube life expectancy.
The Depression, the party line, and the art of listening. In the early 1930s, having a private telephone line became a luxury many New Haven families could no longer afford. To keep the city connected without laying thousands of miles of new copper, SNET popularized the party line. This was a single circuit shared by 2, 4, or sometimes even 8 different households. The technical boredom of the ring. The party line was a masterpiece of boring engineering. Since everyone was on the same wire, the exchange had to figure out a way to signal only one house at a time. This was done through coded ringing. Imagine sitting in a quiet house in Westville, New Haven in 1934. The phone on the wall starts to ring. You don't just pick it up, you listen to the pattern. One long ring, that's for the Smith family down the road. 2 short rings, that's for the baker on the corner. A long and a short, that's finally for you. Inside the New Haven Exchange, this required a specialized ringing machine, a rotating motor with different cams that physically opened and closed the circuit to create these specific rhythmic pulses. If the motor's speed fluctuated even slightly due to a drop in the city's power grid, the rings would sound off, leading to a flurry of confused neighbors picking up each other's calls. The rubbering phenomenon. Because the line was shared, anyone on the party line could lift their receiver and listen to your conversation. In the sociological history of Connecticut, this was known as rubbering. From a technical standpoint, this created a loading problem. When a second or third person lifted their receiver to eavesdrop, the electrical resistance on the line changed. The volume of the original call would suddenly drop, becoming faint and tinny. Experienced New Haven callers knew the moment a neighbor was listening because of that telltale click and the sudden dip in decibels. The 302, the workhorse of the exchange. While the economy was stagnant, SNET began introducing the most iconic telephone of the 20th century, the Western Electric 302, designed by Henry Dreyfuss. This phone was a marvel of boring durability. It was the first phone where the bell, the ringer, was actually housed inside the base of the phone rather than in a separate box on the wall. The casting, the early models were made of heavy zinc alloy, giving it a cold industrial feel. The feet, it had small leather pads on the bottom to prevent it from scratching the polished wood of Depression-era side tables. The dial was tuned to a specific frequency, roughly 10 pulses per second, to ensure it could communicate perfectly with the mechanical step-by-step switches back at the Chapel Street office. The 302 was designed to last for 20 years without a single service call. It was a device of extreme reliability and zero excitement, becoming a silent fixture in the hallways of New Haven, witnessing the quiet years of the mid-1930s. The maintenance of the drop wire. For the linemen in New Haven, the 1930s were spent repairing drop wires, the single pair of wires that ran from the telephone pole to the house. In the salty, humid air of the Connecticut coast, the rubber insulation on these wires would alligator, cracking and peeling until the copper was exposed to the rain.
The evolution of the exchange at this point was a battle of chemistry. SNET engineers experimented with different types of braided cotton and asphalt-saturated jackets to protect the wires from the New Haven weather. It was a slow, repetitive process of replacement, one house at a time, ensuring that the faint hum of the dial tone survived the decade. The war years and the number please discipline. By 1941, the central office in New Haven on Church Street became a high-security hub. Telecommunications were the nerves of the nation, and in a coastal city like New Haven, home to Winchester Rifling Arms and other major factories, the exchange was a primary target for potential sabotage. The boring sacrifice, copper rationing. During the war, the evolution of the physical exchange practically froze. Copper was needed for shell casings and wiring in fighter planes. SNET issued a citywide request, don't call unless it's necessary. For the first time in history, the exchange grew by shrinking its capacity. The held order list, thousands of New Haven residents who wanted new phone lines, were put on a waiting list that lasted for years. Wire conservation. Linemen were trained to splice together tiny scraps of wire that would have previously been discarded. The boring task of soldering short bits of copper became a daily ritual of patriotism. The lead recovery. Old abandoned lead cables buried under the streets of New Haven were meticulously dug up and melted down for the war effort. The information operator and the DA. With the influx of soldiers and factory workers into Connecticut, the information desk, directory assistants, became the busiest corner of the New Haven exchange. This was the era of the DA operator. Unlike the regular switchboard operators who simply plugged in cords, the information operators sat on long desks with massive rotating drums called rotaries. These drums held the most up-to-the-minute lists of every resident and business in New Haven. 1. A caller would ask for a name. 2. The operator would manually spin the heavy metal drum to the correct letter. 3. She would scan thousands of lines of fine print with a magnifying glass. 4. She would read the number aloud in a standardized, non-emotional tone. The evolution here was in linguistic standardization. SNET developed a voice technique manual. Operators were taught to pronounce numbers with distinctive clarity. For example, 3 became 3 and 9 became 9. This was to ensure that even through the static of a worn-out wartime wire, the message was never lost. The arrival of area codes, non-geographic procedure. As the war ended in 1945, a massive problem loomed. The country was a patchwork of local exchanges that couldn't easily talk to each other without multiple human operators. In 1947, the North American Numbering Plan was drafted, and Connecticut was given one of the most prestigious designations, 203. The choice of 203 wasn't random. It was boring engineering at its finest. On a rotary dial, the number 2 took only 2 pulses, 0 took 10, and 3 took 3. Lower pulse counts were easier on the mechanical step switches. Because Connecticut, specifically New Haven and Hartford, were high-traffic areas, it was given a low-pulse code to reduce the physical wear and tear on the Strowger switches. The post-war quiet maintenance. After the tension of the war, the New Haven Exchange entered a period of deep maintenance. Thousands of miles of drop wires that had rotted during the copper shortage had to be replaced. The exchange began using polyethylene instead of rubber for insulation. This was a boring chemical revolution. Polyethylene didn't crack in the Connecticut sun. It didn't peel in the salty air. It was a silent gray plastic that ensured the dial tone would remain steady for the next 40 years. Linemen spent their days in New Haven's alleys, slowly stripping old black rubber and crimping on the new plastic-coated wires. It was repetitive, unglamorous work, but it was the foundation of the modern telephonic age.
The Model 500 and the Great Direct Dial Transition. In 1950, SNET began deploying the Western Electric 500. If the 302 was the workhorse, the 500 was the king of the Connecticut household. It was designed by Henry Dreyfuss again, but with a focus on a boring kind of perfection, the ergonomics of the handset. The physics of the G-type handset. The evolution of the exchange was now happening inside the user's hand. The 500 series introduced the G-type handset. The weight. It was lighter than the old zinc models, made of tough injection-molded plastic. The click. The dial was designed with a governor, a tiny centrifugal brake that ensured the dial returned to its resting position at an exact, unwavering speed. This was crucial because the mechanical switches back at the New Haven central office needed exactly 10 pulses per second to function correctly. The volume. For the first time, a small thumb wheel was placed on the bottom of the phone, allowing the user to adjust the loudness of the bell. This was considered a high-tech luxury in 1953. The death of the operator's cord. While the phones in New Haven homes were becoming colorful, pinks, aquas, and beiges began appearing in Westville kitchens, the exchange itself was undergoing a radical, boring surgery, the introduction of direct distance dialing, DDD. Before this, if you wanted to call your cousin in California from New Haven, you had to speak to an operator who spoke to a long lines operator in New York, who spoke to another in Chicago, and so on. In the mid-50s, the New Haven exchange was upgraded with crossbar switching. Unlike the old step-by-step switches that moved physically like a windshield wiper, the number 5 crossbar was a grid of metal bars and electromagnets. 1. The memory. These switches had markers, primitive mechanical brains that could remember the digits you dialed. 2. The path. The marker would look at the grid, find an open path, and snap the connection into place in milliseconds. 3. The sound. The New Haven office no longer sounded like clicking crickets. It sounded like 1,000 tiny metal clunks happening all at once. The boring geography of 203 and 411. With DDD, New Haveners had to learn to dial 1 plus the area code. This transition was met with a very specific kind of suburban frustration. People weren't used to dialing 10 digits. To help with the transition, SNET launched a massive educational campaign. The exchange evolved into a teaching institution. Every phone bill sent out in New Haven included a small, boring pamphlet titled How to Dial Your Own Long-Distance Calls. It explained the 3-minute rule and the importance of waiting for the dial tone before starting. The dial tone itself was a precisely engineered frequency, a combination of 350 Hz and 440 Hz tones designed to be audible but not startling to the Connecticut ear. The evolution of the protector. Outside, the New Haven linemen were dealing with a new, tedious task, the station protector. As more electronics entered the home, like the first televisions, the telephone lines needed better protection from lightning. Every house in New Haven had a small gray box installed on the exterior. Inside were 2 small carbon blocks separated by a microscopic air gap. If lightning hit the line, the electricity would jump the gap and go to the ground before it could fry the colorful new Model 500 on the kitchen counter. Thousands of these blocks were replaced every year across Connecticut, a silent, repetitive task that kept the network alive through every New England thunderstorm. The touch-tone revolution and the princess of the night. In the early 1960s, the New Haven exchange underwent a subtle but profound mechanical shift. For decades, the pace of the exchange was dictated by the pulse, the slow, rhythmic click, click, click of the rotary dial returning to its home position. But as the population of Connecticut grew, these seconds added up to thousands of hours of wasted line time. To solve this, the Southern New England Telephone Company, SNET, introduced touch-tone service. The physics of the 2-tone harmonic. The transition to touch-tone was an exercise in acoustic engineering. Instead of physical pulses of electricity, the new phones sent musical notes. This was known as DTMF, dual-tone multi-frequency. Imagine the technical precision required. The grid,
Each button on the new push-button pad represented two distinct frequencies. For example, if you pressed the 1 key, the phone generated a low tone of 697 Hz and a high tone of 1,209 Hz simultaneously. The filter, back at the New Haven central office, the equipment had to be upgraded with filters that could instantly recognize these two tones amidst the background static of the copper lines. The boring safety feature. These frequencies were chosen specifically because they are non-harmonic, meaning it is almost impossible for a human voice or a common household noise to accidentally replicate the exact combination of tones and trigger a phone call. For the residents of New Haven, the sound of dialing changed from a mechanical whir to a series of electronic chirps. The Princess phone and the transformer problem. During this period, SNET began marketing the Princess phone to the suburban homes of New Haven. It was small, sleek, and designed specifically for the bedside table. Its primary feature was a dial that glowed in the dark. However, from an engineering perspective, the Princess phone was a logistical headache. 1. The tiny incandescent bulb. The phone used a tiny incandescent bulb to illuminate the dial. 2. The power gap. The telephone line itself did not carry enough amperage to light the bulb without interfering with the voice signal. 3. The solution. SNET technicians had to visit every home that ordered a Princess phone and install a separate, bulky transformer into a nearby electrical outlet. This transformer stepped down the 110-volt house current to a low voltage, which was then wired into the phone. This meant that even for a wireless look, the phone was tethered to a tedious little gray box on the baseboard, a silent monument to the limitations of 1960s power management. The pulp-insulated underground. As New Haven suburbs like Hamden and Woodbridge expanded, SNET began the massive task of undergrounding the main feeder cables. These were not the sleek fiber optic cables of today. These were massive lead or plastic jacketed bundles containing thousands of pairs of copper wires. The insulation inside these cables was often paper pulp. The process, the copper wires were essentially wrapped in a high-grade, wet paper mash that was then dried into a hard coating. The vulnerability, if a construction crew in New Haven accidentally nicked the outer casing of an underground cable, moisture would seep in, the paper pulp would act like a sponge, soaking up the water and causing hundreds of phone lines to short out simultaneously. Linemen spent countless boring hours using desiccants, chemical drying agents, and high-pressure dry air tanks to blow out the moisture from these paper-lined tunnels. It was a slow, invisible battle against the Connecticut water table to keep the dial tones crisp. The 411 directory boom. By the mid-60s, the New Haven directory had become too large for many people to navigate. The 411 exchange became a massive operation. Operators sat in rows using microfilm readers to scan through thousands of names in seconds. The evolution of the exchange was now a race between the human eye and the growing list of Connecticut residents.
The digital brain and the end of the mechanical era. By 1972, the sheer physical space required for mechanical switches was becoming a crisis. The massive crossbar grids were reaching the ceilings of the Church Street building. The solution was the transition from electromechanical switching to stored program control, SPC. The number one ESS, a new kind of boredom. The number one ESS was essentially a massive room-sized computer dedicated to a single repetitive task, connecting path A to path B. Unlike the previous systems, which used physical motion to create a connection, the ESS used ferried switches. The ferried switch, these were tiny glass-sealed reeds that reacted to magnetic pulses. Because there were no moving arms or sliding wipers, the connection happened in microseconds. The software? For the first time, the logic of the New Haven exchange was stored on magnetic plates. If SNET wanted to change how a phone number worked, they no longer had to send a technician with a soldering iron to move a wire. They had to reprogram the exchange.
To the technicians, this was a period of intense stationary boredom. Instead of climbing ladders to oil gears, they sat at maintenance consoles, watching rows of tiny incandescent lamps. If a lamp flickered red, it meant a specific memory module had failed. The work became an endless cycle of pulling out rectangular circuit boards, cleaning the gold contacts with specialized erasers, and sliding them back into the rack. The arrival of custom calling. Because the New Haven exchange was now programmable, SNET began introducing features that felt like science fiction to the average Connecticut resident. These were the custom calling services. 1. Call waiting, a soft, rhythmic beep that interrupted a conversation. Technically, this required the ESS to momentarily park the primary voice signal, inject a 440 Hz tone, and listen for a hook flash, the user tapping the hang-up button to swap the electronic paths. 2. Speed calling. Users could program a one-digit code for frequently called numbers. This was the first time the exchange acted as a memory bank for the user. For the exchange, these features added layers of computational complexity. Every time a resident of New Haven used call waiting, the ESS had to perform thousands of logic gates per second, an invisible dance of electrons that replaced the physical clatter of the 1950s. The splicing of the 70s, the B connector. While the brain was becoming digital, the body of the New Haven exchange, the copper wires in the street, was still very much analog. Linemen in the 70s spent their days in the mud of New Haven's suburbs using a new tool, the B connector, affectionately known as the bean. Previously, connecting two copper wires required stripping the insulation and soldering them, a slow, artistic process. The B connector allowed a lineman to insert two unstripped wires into a small metal-lined plastic sleeve, crimp it with a specialized tool. The internal teeth of the bean would bite through the insulation to create a connection. This was the ultimate boring evolution. It made the work faster, but it turned the craftsman lineman into a repetitive assembly line worker. Tens of millions of these beans were crimped under the streets of New Haven during the 1970s, forming the unseen joints of the city's aging copper skeleton. The arrival of experimental pagers. In the late 70s, the New Haven Exchange began to experiment with the first radio frequency connections. These weren't mobile phones yet, but beepers. A dedicated rack in the central office was connected to an antenna on the roof. When you called a specific number, the exchange would translate that electrical pulse into a radio burst that traveled over the New Haven skyline. It was a primitive beginning to the end of wires, but for now, the wire was still king. The Great Divestiture and the Glass Thread. In 1984, the American telecommunications landscape changed forever with the breakup of AT&T, Ma Bell. However, SNET was in a unique position. Because AT&T only owned a minority stake in the Southern New England Telephone Company, SNET remained an independent entity. While the rest of the country was being carved up into baby bells, New Haven stayed under the familiar orange and blue logo, SNET. The bureaucracy of equal access. The evolution of the exchange during this time was largely invisible and incredibly tedious. It was defined by software partitioning. The problem? Previously, every call made in New Haven was handled by SNET. After the breakup, customers could choose long-distance carriers like MCI or Sprint. The solution? Engineers in the New Haven central office had to spend months reprogramming the electronic switching systems. They had to create equal access software code. The boring detail, every time a New Haven resident dialed 1, the switch had to pause for a fraction of a second, look up that customer's preferred carrier in a massive digital database, and then route the electrical signal to a specific trunk line belonging to a different company. The first fiber optic backbone. While the lawyers were arguing over regulations, the linemen of New Haven were beginning to handle a material that felt like science fiction, fiber optics. By the mid-80s, the heavy, lead-shielded copper cables under Chapel Street were reaching their capacity. There was no more room in the underground ducts. SNET began pulling the first fiber optic threads through the old conduits. This was a boring revolution of scale. One, the size. A single pair of glass fibers, no thicker than a human hair, could carry more conversations than a copper cable the size of a man's arm. Two, the splicing. You couldn't use beans or solder for glass. SNET technicians had to learn fusion splicing. They sat in specialized vans with microscopes and tiny electric arcs, melting two pieces of glass together with perfect precision. If a single speck of New Haven dust got into the splice, the light signal would scatter and the connection would fail. The signal, unlike copper, which used electricity, these glass threads used pulses of light. The exchange now required optoelectric converters, racks of humming lasers that turned your voice into flashes of light. The arrival of the cell. In 1983 and 1984, the New Haven Exchange saw the birth of something that would eventually destroy the landline: cellular technology. SNET launched one of the first commercial cellular networks in the country, right here in Connecticut, under the name SNET Mobility. The evolution was purely geographical. Engineers divided New Haven into cells. A low-power radio tower was placed on a hill or a tall building. Each tower was connected back to the Church Street Exchange by a dedicated T1 line. The handoff? The most boring yet complex part of this evolution was the software that managed the handoff. As a car drove from New Haven to Hamden, the exchange had to perfectly time the transfer of the signal from one tower to the next without dropping the call. In the early 80s, this was a clunky, experimental process. The phones were bricks that stayed in the car, and the voice quality was often worse than the 1920s iron wires, but the cord had finally been cut.
The digital dial-up and the noise of the future. By 1992, the New Haven Central Office was undergoing a massive boring crisis of duration. For nearly 100 years, the exchange was engineered for the 3-minute call. People picked up the phone, said what they needed to say, and hung up. BBS. The behavior of the 203 area code changed overnight. The problem: instead of 3 minutes, users were staying connected for 3 hours. The impact: the switching equipment in the Church Street office was being held open. Because the old mechanical and early electronic switches had a finite number of physical or logical paths, a few hundred teenagers surfing the early web could effectively block their neighbors from getting a dial tone for emergencies. The solution: SNET engineers had to perform load balancing on a scale never seen before. They moved data-heavy users to different line groups and began installing digital subscriber line access multiplexers, or DSLAMs. This was the start of separating the voice from the noise. The anatomy of the 56K screech. If you lived in New Haven in 1996, the most common sound in your house was the handshake of the modem. This sound was actually a sophisticated, boring negotiation between your home and the exchange. The dial. Your computer sent touch-tone pulses to the ESS. The handshake. The screeching sound was the modem testing the cleanliness of the copper wire. It was checking for quantization noise, the tiny errors introduced when the New Haven Exchange converted your analog voice into a digital 64 kbps stream. The compromise. If the copper wire under your New Haven street was old or damp, the modems would negotiate down to a slower speed, perhaps 28.8K. Technicians spent their days at the MDF in New Haven, cleaning terminals and replacing old cross-connect wires just to give users an extra few kilobits of speed. It was a battle for the last mile of copper. The final switchover. By the late 90s, the evolution reached a point of no return. SNET was acquired by SBC Communications, which eventually became the new AT&T. The New Haven Exchange began decommissioning its last electromechanical parts. The cutover was the ultimate boring milestone. At exactly midnight on a chosen Tuesday, engineers would stand in the silent Church Street building. With a few keystrokes, they would migrate thousands of New Haven lines from the old electronic switches to a new soft switch, a server that existed more as software than as hardware. The physical clank of the 20th century was officially replaced by the silent blinking of a server rack. The rise of the NID, or Network Interface Device. Outside the New Haven homes, the old gray protector boxes were replaced with network interface devices, or NIDs. These plastic boxes contained a simple but revolutionary feature, a test jack. It allowed the customer to plug a phone directly into the SNET network, bypassing their own home's wiring. This was a bureaucratic evolution. It allowed SNET to say, the problem is in your house, not our exchange, ending the era where the phone company was responsible for every inch of wire in Connecticut.
The silent switch and the ghost of the copper wire. By the early 2000s, the Southern New England Telephone Company, or SNET, had been fully absorbed into the global hierarchy of the new AT&T. In the New Haven central office, the massive humming racks of the 1970s and 80s were becoming legacy equipment, monuments to a slower time. The rise of VoIP and the soft switch. The most significant boring evolution of this decade was the transition to VoIP, Voice over Internet Protocol. In the past, when you picked up a phone in New Haven, you opened a dedicated physical circuit to the exchange. Now, your voice was chopped into tiny digital envelopes called packets. The packetization. Your hello was broken into thousands of pieces, each labeled with an IP address. These packets didn't necessarily travel the same path. One might go through a server in Hartford while another bypassed through New York, only to be reassembled in milliseconds at the destination. The soft switch. The switch was no longer a machine, it was a server. In the New Haven office, a single rack of servers replaced rows and rows of Crossbar and ESS equipment. The sound of the exchange changed from a mechanical clunk or an electronic hum to the high-pitched sterile whir of cooling fans in a climate-controlled data center. The mining of the central office. A strange, tedious phenomenon occurred during this period, the deconditioning of the New Haven buildings. Because the new digital switches were so small, the massive exchange buildings on Church Street and Chapel Street suddenly had vast amounts of empty space. Copper mining. For the first time in history, SNET began mining its own buildings. Miles of old, redundant copper wiring, some of it dating back to the 1940s, were pulled out of the ceilings and floors to be recycled. The weight shift. Engineers had to calculate the structural integrity of the buildings as the weight of the equipment dropped from hundreds of tons to just a few thousand pounds of server racks. The history of New Haven's voices was literally being hauled away in scrap trucks. The death of the dial tone. For over 100 years, the dial tone was the heartbeat of New Haven. It was the signal that the exchange was alive and ready. But with the shift to digital and fiber optics, like the rollout of AT&T U-verse in the mid-2000s, the dial tone became an artificial construct. In the simulation, in a modern digital line, there is no live circuit waiting for you. When you pick up the phone, the software simply plays a recording of a dial tone to make you feel comfortable. The latency. Technicians spent their time managing latency, the delay in the packet travel, rather than static. If the delay was more than 150 milliseconds, the human brain would perceive it as an echo. The boring task of the decade was packet shaping, prioritizing voice data over someone else's cat video download to ensure the phone call remained clear. The legacy of 219 Chapel Street. As we look at the New Haven Exchange today, the physical spiderwebs of George Coy's era are gone. The teenage boys, the hello girls, the clicking Strowger switches, and the copper beans are all relics of a bygone industrial age. But the logic remains. The 203 area code still identifies a geographic community. The central office still stands as a hub, even if it now houses routers instead of operators. The evolution of the first telephone exchange in Connecticut is the story of a city moving from the heavy, tactile world of iron and paper to the weightless, invisible world of light and code. George Coy's dream of a connected city has been achieved so thoroughly that we no longer even notice the wires, or the lack of them. The hybrid era and the maintenance of ghost circuits. As New Haven entered the 2010s, the exchange reached a strange middle age. While high-speed fiber was the goal, the reality was a messy, boring layer of hybrid technologies. The Southern New England Telephone Company's old copper didn't just disappear, it stayed in the ground, becoming what engineers called abandoned-in-place infrastructure. The dry loop and the DSL maintenance. In the early 2010s, many New Haven residents still relied on DSL, digital subscriber line, provided over the old copper wires. This created a specific kind of technical boredom for the exchange technicians. The bridge tap. Over a century of growth, many copper lines had bridge taps, extra lengths of wire that branched off but led nowhere. For voice calls, they were harmless. For high-speed data, they acted like electronic echoes, bouncing the signal back and destroying the internet speed. The boring hunt. Technicians spent weeks in the New Haven manholes tracing a single pair of wires through 1940s lead-sheathed bundles, manually clipping off these dead ends to gain a few extra megabits of speed for a suburban household. The preservation of 911 reliability. One of the most tedious but vital evolutions of the exchange was the E911 system. In the old days, a call to 911 just went to the local station. In the digital age, the New Haven Exchange had to communicate with a massive database to provide an exact address for a landline or a GPS coordinate for a cell phone. The database scrub. Every single day, clerks in the New Haven office had to scrub the Master Street Address Guide, or MSAG. If a new apartment complex was built near Yale, every individual unit's location had to be manually entered into the exchange software. If a street name changed, the database had to be synchronized. This was the invisible bureaucratic work that ensured that when a phone was picked up, the exchange knew exactly where the caller was standing. The physical deloading of Connecticut. Remember the loading coils we discussed in Part 7? Those heavy iron pots that helped voice travel long distances? In the 2010s, those very coils became the enemy. The conflict. Loading coils were designed for 3,000 Hz voice signals. Digital signals, DSL, operate at much higher frequencies. A loading coil acts as a filter that completely blocks high-speed internet. The removal. Linemen had to go back to the exact same poles their grandfathers climbed in the 1920s to find these iron pots and bypass them. It was a reverse evolution, removing the advanced tech of the past to make room for the advanced tech of the present. The architecture of the data hotel. The grand Art Deco building on Church Street evolved into a data hotel. Instead of rooms full of operators, the building now featured co-location racks. Companies rented floor space to put their own servers next to the exchange's backbone. Massive HVAC systems. Because servers generate intense heat compared to human operators, the exchange buildings had to be retrofitted with massive industrial cooling units. The hum of New Haven's connectivity was no longer the sound of voices, but the steady, heavy drone of air conditioning fans.
The sunsetting of the copper grid. By 2018, the cost of maintaining the aging copper infrastructure in New Haven had become unsustainable. The southern New England landscape, with its humid summers, salty coastal air, and freezing winters, had taken a toll on the millions of miles of copper buried under the streets. The retirement of the central office switch. In the New Haven central office, the evolution was no longer about adding new features, it was about evacuating the old switches. The transition, AT&T and SNET began moving the final landline customers onto IP Lite, or virtual switches. The hardware fade. The massive electronic switches that once took up entire floors were replaced by software running on commodity hardware, standardized servers. The boring task.
technicians had to perform hot cuts. This involved migrating a live phone line from a 40-year-old hardware switch to a new digital cloud-based system without the customer ever noticing. It was a delicate, repetitive process of checking voltage levels, verifying dial tones, and clicking enter on a keyboard. The rise of the fiber to the premises, or FTTP. While the copper was sunsetting, a new, even more boring physical labor was taking place, the rollout of fiber to the premises. In neighborhoods like East Rock and Westville, the old black drop wires were being replaced by thin, flexible strands of glass wrapped in sturdy black plastic. Imagine the tedious precision of this new era. 1. The slack storage. Because glass cannot be bent at sharp angles like copper, every house in New Haven now required a slack storage box, a small plastic coil where extra fiber was looped in a perfect circle to prevent the glass from snapping. 2. The ONT, the optical network terminal. The exchange effectively moved into the customer's basement. The ONT is a small device that converts light pulses back into electrical signals. It requires its own power supply and often a battery backup, a far cry from the old days when the phone worked even when the house's power was out. The 5G small cell integration. As the 2020s approached, the New Haven Exchange expanded its reach into the very air of the city. The evolution was no longer about massive towers, but about small cells. The stealth infrastructure. Instead of one large tower on a hill, hundreds of small, lunchbox-sized antennas were attached to New Haven utility poles and streetlights. The backhaul. Every single one of these small cells had to be connected back to the Church Street Exchange via a dedicated fiber optic line. The boring reality. This meant more digging, more trenching, and more splicing vans parked on the corners of Chapel and streets. The exchange had become a literal nervous system where every limb, the cell towers, was tied back to the brain, the central office, by a thread of glass. The finality of 2026. Standing in New Haven today, the evolution is complete. The exchange is now entirely digital. If George Coy walked into the modern facility, he would find no wires to touch, no brass pins to polish, and no teenage boys to yell at. He would find a quiet, air-conditioned room filled with the blue glow of servers. The first telephone exchange in Connecticut didn't just evolve, it became the foundation for the entire modern world. Every time a New Havener sends a text, makes a video call, or streams a movie, they are using the evolved descendants of the Bustle-Wire switchboard. Since we have reached the conclusion of the chronological history from 1877 to 2026, we will now transition into a deep dive technical appendix. This part is designed to be the most boring yet most atmospheric section of your audio story, focusing on the minute, repetitive sounds and the specialized tools that defined the Connecticut Exchange's daily life. This is perfect for the sleep story effect. The tools of the trade and the sounds of the switch. To truly understand the evolution of the New Haven Exchange, one must look at the hands of the people who built it. The history is etched in the steel of their tools and the specific frequencies of the noises that filled the central offices for over a century. The linemen's pliers. For over 100 years, the most important tool in New Haven was the side-cutting pliers, often called clines. The weight. These were heavy, forged steel tools. A lineman in 1910 used them to grip the stubborn galvanized iron wire, twisting it into a Western Union splice. The texture. The handles were originally bare metal, then wrapped in friction tape, and finally dipped in thick yellow or red plastic insulation. The sound. The rhythmic snip-snap of copper being trimmed and the clink of pliers hitting a leather tool belt formed the percussion of the New Haven streets for decades. The butt set and the dial tone. Until the very end of the 20th century, the most iconic piece of equipment was the test set, or butt set. It looked like a heavy, oversized telephone handset with large alligator clips on the end. The connection. A technician in a New Haven manhole would clip on to a pair of wires. The monitor mode. They would listen silently to ensure no one was talking, to respect privacy. The talk mode. They would draw dial tone directly from the Church Street Exchange. The soundscape. In your sleep story, imagine the sound of a rotary dial being flicked by a thumb, the slow, mechanical zzz-tup, zzz-tup, followed by the steady, low-frequency hum of a 1950s dial tone. It was a comforting, electrical aum that signaled the system was healthy. The heat coil and the protection frame. Inside the New Haven Exchange, there was a specialized component called the heat coil. Its job was incredibly boring. It waited for a mistake. If a power line accidentally touched a telephone wire somewhere in New Haven, the heat coil would sense the rising temperature. The action, a small drop of solder inside the coil would melt, causing a spring to pop and disconnect the line before the fire could reach the expensive switching equipment. The maintenance. After a summer thunderstorm in Connecticut, technicians spent hours walking the mainframe looking for these tiny popped springs. It was a silent, repetitive task of replacing thumb-sized cylinders one by one across a wall of 10,000 connections. The wiping of the lead sleeve. Before plastic was invented, the giant cables under New Haven were spliced inside lead sleeves. This was a metallurgical art form. The process, a technician would slide a lead tube over the wire splice. Then they would use a wiping cloth and molten lead, solder, to create a waterproof seal. The sensation, the smell of melting lead and the hiss of the soldering torch in a quiet New Haven alleyway were the smells of progress. The finished splice looked like a smooth silver football. These footballs still sit under the streets of New Haven today, holding the silent remains of 1940s copper.
The social rhythms and the information era. By the 1950s and 60s, the New Haven Exchange wasn't just a technical hub, it was a social regulator. The Southern New England Telephone Company, SNET, didn't just sell service, it sold etiquette. The evolution of the exchange during this time was reflected in the quiet hours and the standardized grace of the operators. The Blue Book of Etiquette. SNET frequently issued how to use the telephone guides to New Haven households. This created a specific, boring yet comforting suburban ritual. The greeting. Residents were taught not to just say hello, but to identify themselves immediately. The Miller residence, Susan speaking. The 3-minute social pressure. Because many New Haven families still shared party lines, as we saw in Part 9, a phone call was never truly private. The social evolution here was the development of the quick call. Staying on the line for an hour was considered a grave social sin in neighborhoods like Westville, as it blocked the exchange for others. The 111 room, the quietest place in New Haven. If you could walk into the SNET building on Church Street in 1965, the most striking thing wouldn't be the machines, but the silence. In the directory assistant's 411 room, dozens of women sat in padded chairs. They didn't shout, they spoke in the voice with a smile, a low, melodic, and perfectly modulated tone designed to be audible over the hum of the cooling fans. 1. The manual search.
Before computers, these operators had key rec files, massive rotating mechanical drums that held every name in the New Haven exchange. 2. The rhythm. You would hear the shuff, shuff, shuff of the paper pages turning, followed by the soft thump of a finger landing on a name. 3. The information culture. These operators often became the human search engines of New Haven. They knew the numbers of every bakery on Grand Avenue and every doctor near Yale by heart, bypassing the books entirely to save time. The night shift and the quiet hours. Between 2 a.m. and 5 a.m., the New Haven Exchange entered a state of electrical sleep. The traffic drop. In the 1950s, the number of calls would drop to almost zero. The massive banks of mechanical switches would stop their frantic clicking. The sweep. This was when the maintenance crews did the most boring work. They would walk through the silent aisles with specialized vacuum cleaners and soft brushes, removing the tiny flakes of carbon and dust that had settled on the electrical contacts during the day. The sound. In the vast, dark rooms, you could hear the steady tick-tock of the master clock that synchronized the billing system, punctuated by the occasional clack of a lone late-night caller's connection being made. The SNET man as a neighborhood fixture. The evolution of the exchange was personified by the SNET man in his iconic green or white van. To the children of 1960s New Haven, the arrival of the phone man was a major event. The tools. He carried a tool pouch on his hip and a staple gun to secure the wires along the baseboards of the house. The drop. He would climb the pole, hook his leather belt around the wood, and lean back with total confidence, a human bird perched over the Connecticut streets. The legacy. He represented the face of the exchange. He wasn't just fixing a wire, he was maintaining the social fabric of the city, one drop at a time. The urban archaeology of the 203. The evolution of the New Haven Exchange didn't just happen in a vacuum, it left a physical crust on the city. If you walk through New Haven today, the history of the Southern New England Telephone Company, SNET, is still there, beneath the layers of modern paint and asphalt. The manhole covers of a century. If you look down while walking near the New Haven Green, you will see heavy iron lids with different inscriptions. SNET Co. These are the most common, dating from the mid-20th century. Southern New England Telephone, older, more ornate lids with serif lettering. The Bell logo. Occasionally, you might find a rare lid featuring the iconic Bell System logo, a reminder of the brief periods of total national integration. The engineering. These lids weren't just decorative, they were engineered with specific ribs on the underside to handle the weight of the trolley cars and later the heavy trucks of the industrial age. They protect the vaults where the 1890s lead cables meet the 2020s fiber optics. The ghost insulators. In some of the older industrial sections of New Haven, near the old factories or the railroad tracks, you can still see the ghost insulators. The remnants. High up on the eaves of brick buildings, you might spot a single small green or clear glass knob. The history. This was the entry point where the drop wire once entered the building. The glass was designed to prevent the electrical current from the telephone line from leaking into the damp brickwork during a Connecticut rainstorm. Today, they're empty, holding no wires, but they mark the exact spot where a New Haven business first joined the global network 100 years ago. The concrete telephone booth pads. Before the 1990s, New Haven was dotted with thousands of public payphones. While the booths are gone, the footprints remain. The evidence. You can often find a small, square concrete pad on a sidewalk that seems to serve no purpose, or a set of 4 rusted bolts cut flush with the ground. The infrastructure. Beneath these pads lie the stub-outs, the ends of the copper pipes that once carried the coins and the voices of New Haven's travelers. They are the fossils of a time when communication was a public utility rather than a private pocket-sized device. Final thoughts. The invisible city. The evolution of the New Haven Exchange is the story of how a city became nervous. From the first erratic vibrations of a galvanized iron wire in 1878 to the silent, light-speed pulses of 2026, the Exchange has been the invisible architect of New Haven's growth. George Coy's Bustle-Wire switchboard didn't just start a company, it started a way of life. Every time we connect, we are walking the path laid down by the teenage boys, the hello girls, the SNET linemen, and the silent, clicking mechanical brains of the Church Street office.
History is full of secrets, and we are just getting started. If you enjoyed this journey, make sure to hit the like button. It really helps the channel. What part of this story surprised you the most? Tell me in the comments. And if you haven't already, subscribe and turn on notifications so you're always the first to join us for our next deep dive. Thanks for watching, and I'll see you in the next one.